Good morning, and today we're going to go over 10.1 to 10.4. We're going to use all the concepts we used on the video that I made last week that you watched Thursday or Friday or over the weekend. The intro to graphing higher degree polynomial functions. So we're going to continue with all that. So if you have questions on some of the things that I'm doing here, make sure you go back and watch that video where I maybe better explain what we're doing and how we're doing it. Okay, for these functions, find the key characteristics. Now, in Sketch the Graph, we're focusing on no calculator stuff. However, the TI Inspire we're going to use to find some of our turning points. So if you recall, when we looked at it, and this was on page 292, I said, okay, you get a general shape without the calculator, what this looks like, but we don't know where this turning point is or how high it is, or this one down here. I don't know if I hit my y-intercept on the way back up or on the way down, okay? Those are things that we can kind of clean up and we can confirm with the calculator when we're done giving a rough sketch without the calculator, okay? So for this one, the degree of the polynomial, it looks like we have a negative lead coefficient. We have an x and then times an x squared. So that's going to be, degree is going to be 3, which means there are 3 total zeros we're looking for. X-intercepts, so 5, 0, and -1, 0. Now notice this one has a multiplicity of 2, so this one's a double zero, okay? Which means there's going to be a bounce. Okay, the y-intercept, we can plug in 0 for x. We'll get -5. Plug in 0 for x. We get 1 squared. That's going to be -5 times 1. So 0, -5. Okay, our domain, well, let's look at our end behavior. This is third degree with a negative lead coefficient. So the end behavior is going to be up on the left and down on the right. Okay. And since we go up all the way to positive infinity, and we know that this is connected, and we'll go down to negative infinity, we know our range is all real numbers, so negative infinity to positive infinity. We also know our domain is all real numbers. There's no restrictions on what we can plug in for x. Okay, we're going to have a graph as x goes all the way to positive infinity and all the way to negative infinity. So all real numbers again. Third degree, so the maximum number of turning points is 1 less than that, or 2. Number of roots, total number is 3, but these 2, this counts as 2, but they're not distinct because they're the same one twice. So there's only 2 distinct roots or zeros. Okay, so let's plot our intercepts. 5, 0, -1, 0. Remember, this one's a bounce at -1, 0. And we have 0, -5. My end behavior up on the left, down on the right. Okay, so up on the left, after we go here, we're going to go up. I'm going to pass through here. I'm not going to pass through there. Remember, that's a bounce. Okay, and that y-intercept, let's fix that too, because that's not negative, that's positive. The reason that's positive is because when we plug in 0 for x, that's a negative times a +1, and then we have another negative. So that's 0, +5. The nice thing about doing these problems is sometimes you start to figure things out and you realize, ooh, that doesn't make sense. Let me double check that. Okay, my end behavior is here. My y-intercept is +5, and that makes more sense because I'm going to pass through here. I know I have to bounce here, and I know my end behavior on the left is up. If I look over here on the left, I'm going up. Off to the right, I know I'm ending up going down. Okay, and then I know I'm going to bounce there. I'm going to go through here. I'm guessing that's going to continue up. I don't know how high. I'm going to guess about there right now, and then we'll clean it up. Okay, we're going to need the calculator to clean that up. And this one is just has a multiplicity of 1, 5, 0. That only occurred once. It's not x minus 5 squared, so I know I'm just going to pass through there. Okay, now if you go to your calculator, I've actually already graphed this one. Now I'm going to update my window menu for, I want my y value to be a little bit higher. So go down to my y max. Let's go up to about 20. Sometimes you just kind of play with it. That's not even high enough. I have to go higher. Let's go back to menu. Number 4 for window, number 1. I want my y value. I want to see this turning point right here. How high up do I go for this turning point? Let's make it 50. Okay, so to find that turning point right there, oh no, let's see. There's a little bit of a glare here. I think I can adjust that, and you can see that a little better there. Okay, so I want to see where that turning point is. So I'm going to go to menu. Here I go to analyze graph number 6, and I'm going to go to maximum. So we're finding a maximum, not the max on the entire function, but we can find the maximum on an interval. It's asking me for a lower bound. So I can use the touchpad and bring this over, and I'm going to give it an interval. Bring that over. Somewhere it wants a lower bound, so I have to go to the left of that top point, hit enter. And then I go to the right, and it's going to give me that maximum right there. I don't know if you can see that. That says 3,32. 3,32, you can kind of see it. If I go here and hit enter, it's going to give me that 3,32. Okay, so the best we can do, now this is going to be way off the page. So I'm just going to go up here. Yeah, it's not perfectly drawn to scale because my page isn't big enough. But I can still plot that point at, what was it, 3,32? I guess it should be above the 3 here. So maybe bring it over here. Okay, so 3,30. Obviously, it's going to be much higher, but that's my max there. Okay, I'll make that look a little bit better. It passes through there and goes down. It shouldn't have this weird funky curve in it. That should be a smooth curve. So it's going to go through here, keep going down. Okay. All right, let's go to the next one. Okay, label that point 3,32, 5, 0, negative 1, 0. All right, let's go to the next one. Okay, the degree of the function, there's 1x, there's an x squared, and another x, so it's 4th degree. X-intercepts at negative 3, 0, negative 1, 0. This one's a double. So there's going to be a bounce. And then at 2, 0. So at negative 1, 0, I've got a bounce. At negative 3, 0, and at 2, 0. Y-intercept, if I plug in 0 for x, I'm going to get 3 times 1 squared times negative 2. That's going to be negative 6. 0, negative 6, 1, 2, 3, 4, 5, 6. Domain is going to be all round numbers. Now be careful here, the range or your possible y values. This one, because it's 4th degree, remember 4th degree with a positive lead coefficient, if you were to multiply this entire thing out, your x to the 4th term would be positive. So your end behavior is up on the left, up on the right. Okay, which means your range is not going to be all real numbers. We're going to have to find a little more information. We can't tell the range just yet. 4th degree, maximum number of turning points is 3. Number of distinct roots, remember there's 4 roots because there's 4 zeros, but there's only 3 distinct roots. This one, or these two, the negative 1, 0 and negative 1, 0, because that occurs twice, that is 2 zeros, counts as 2, but only 1 distinct. Okay, so there's 3 distinct zeros. Okay, and let's sketch this from here. Our bounce is here. I know after I go through this point, I'm going to go up because my end behavior on the left is up. After this point, I'm going up. I'm going to go down. I don't know how far, but I know that I'm going to bounce here. Now the bounce, you don't necessarily if you're bouncing from below or from above. So that you have to kind of piece together with your other zeros and with your intercepts and your end behavior. Okay. This is going to go through here at 0, 6, and we don't know how far down before it's going to go back up. That we're going to find with the calculator. That we can find our, that's going to help us find our range, but also we want to find the turning point. Okay, so the rest, this much we've done, we can do with the calculator. or without the calculator, let's go to the calculator to do the rest. So I'm going to go to the next one. I've actually already graphed this one. Move this out of the way, save some time, but you can go ahead and pause this and graph this on your own. Okay, so looks like this turning point I've got to find, and I've got to find another turning point down here. So I'm going to make my Y min go down further. So let's go to Menu, Analyze Graph again. Oh, no, I'm sorry. I don't want to do that yet. I want to go to Window. I'll come back to that in a second. Window Settings. My Y min, I want to go, let's go down to -30, see if that's enough. Yeah, that's enough. Okay. So now let's do analyze graph. We have to find this minimum, this low point, and this minimum. So Menu, 6. We're going to go to minimums this time. And go to the left. We want to find this one right here first. So we're going to go to the left of there. It's asking for a lower bound. Hit enter, and then go to the right. Actually, I think this is what's nice about this new calculator. I think maybe we can get them both at one time, or maybe not. Nope, it just does one. So let's do it again. So that one we have there. Menu, analyze graph, minimum, number 2. Let's find this one. It only wants to do one at a time, because it's finding the minimum on this interval. Okay, so let's move this out of the way, and we want 3 decimal places. Okay, and if yours is not showing 3 decimal places, I'll show you the setting to do that in a moment. But let's put these in here. So that's going to be -2.3 and -5. So I didn't guess that too well. My Y value is -5.17. About here, doesn't have to be perfect. So that's going to be -2.397, comma, -5.174. Okay, and let's fix that. That's why we always use pencil. That's going to be a minimum or a turning point. I'm going to bounce off here. And let's find this minimum. That's going to be at -16. Okay, so that's going to go down further. I can almost fit this on our graph if I go down 6 more. 1, 2, 3, 4, 5, 6. A little more than 6. My X value is 1.14. So I'm going to be about here. Doesn't have to be perfect. Okay. Y-intercept was -6. I go through there, come down to this point, and back up. Okay, so this point here, 1.147, comma, -16.306. Okay, if you want to know, if you're not showing 3 decimal places on the calculator, you go to, I believe it's under Menu right here, Menu Settings, and you want the graph settings. See how I have display digits, float 6, it's going to give me 6 digits. If I wanted more, I could do float 7. Usually 6 is enough. Okay. Yours might say auto, which I'm not sure what it does for auto. It might say float 1, 2, or 3, but try float 6 and hit enter, and it should give you more decimal places there on your calculator. Okay, let's go to the next one. Now, if you want to stop here and try these next 2 on your own, if you feel like you know enough, by all means, stop, do them on your own, and just check the answer key. You don't have to listen to every minute of this if you've already picked up all the information. But if you want, I'm going to go through the next 2 just to make sure you're solid on this, okay? The degree, I've got an x, and then I've got an x squared. So the degree is 3. My x-intercepts are 3, 0, and -2, 0. Now notice this is a double 0. Is that x plus 2 has a multiplicity of 2. Occurs twice, so there's going to be a bounce. Y-intercept, plug in 0 for x, and we get 2 times -3 times 2 squared. So 2 times -3 is -6 times 4, -24. The domain, all real numbers. Spoiler alert for these polynomial functions. Your domain is always all real numbers. Now your range, that's going to depend. My degree is 3. My lead coefficient's positive, so my end behavior is down and up. So if your n behavior is different directions, you know that it's going to hit every y value, and your range is going to be all real numbers also. Okay. Degree is 3, so we're going to have a maximum of 2 turning points, always one less than the degree. Number of distinct roots, well, there's 2 distinct roots. Remember, 3 total. The double zero doesn't count as 2 distinct. It counts as 2 when you're trying to make sure you account for all that add up to the degree, but it doesn't count as 2 different and distinct roots. Okay, there's only 2. Okay, so my y-intercept is down 24. 3, 0, and negative 2, 0. If you want to rescale your axes, you can. I'm not going to. 3, 0, and negative 2, 0. 0, negative 24. That's going to be way, it would be way down here. But we're going to just say it's down here. 0, negative 24. Okay, not quite drawn to scale, but that's okay. And the bounce is here. So there we know there's a bounce. We know our end behavior on the left, if we look up here, is down. So after we bounce off this axis, we're going to go down. And we're going to go this way. We're going to go down all the way to this 0, negative 24. I'm going to guess that's not our minimum, and we're going to go even further down and come back up. But we don't, that part we're not going to know until we graph it. Okay. So I believe all we have to do is find this point right here with the calculator. Okay, so I'm going to go to the next page where I've already graphed this one. 2 times x minus 3 squared, x plus 2 squared. Okay, so that y value down there is really far down. Let's go to menu. You know what? I'm going to show you something else. If you want to go ahead and find that minimum value right now, I believe that the calculator actually readjusts the window for you. Let's try it. Analyze graph number 6. Let's find that minimum value. I'm going to go somewhere to the left of that minimum. I know that this is going down. This graph was down here somewhere and comes back up. Okay, so left bound, hit enter. Now it's asking for an upper bound. I'll go to the right. Let's see if it adjusts the window for us. It kind of did. It's not perfect because it adjusted everything. Okay, so our y values, that's good. But let's change this. I want to see this graph better. We're going from negative 66 to positive 66. I'm going to change that. I'm going to go to menu, window number 4, and I'm going to do window settings. Now my x min and max, I'm just going to go negative 5 to positive 5. Let's see how that looks. Okay, that's much better. I just needed to zoom in and see this better. So right there, that's going to be where we hit our graph at negative 2. This minimum value here is 1.333 comma negative 37.037. Okay, so I'm going to plot that on here. Again, this is a little bit off, not being on scale. 1.333 comma negative 37.037. And that's all we got to do for that one. Okay, and one last problem. Again, I encourage you, try these on your own if you want to try them on your own. And if not, join me and we can go through another one. Okay, but for homework, you're going to do the next 3 pages because you're going to have plenty of practice on your own, and I will post solutions, answer keys to those so you can check your work. You can also, the nice thing about this is you have your calculator. So even if you didn't have an answer key, you can type it in the calculator and you can see what your answer should have been. Okay, so the degree of the function, this is 3rd degree. Notice this one's not factored, so we're going to have to factor this. We could use the same thing we did last week where we find the factors of 12, plug them in, find what becomes 0. But you know what? I'm noticing something. This is x cubed plus 3x squared. There's a negative 4x minus 12. This 1 to 3 and negative 4 to negative 12, those are the same ratios. I think I can factor this by grouping. I think out of the first 2, I can factor out of x squared. And I've got x plus 3. And out of these 2 terms, I can factor out a negative 4. Minus 4 times x plus 3. So I've got a common factor. Factor out the x plus 3 from both terms. I'm left with x squared minus 4. So I've got x plus 3, x minus 2, and x plus 2. Okay, so it's nice to know different methods of factoring because that was a lot easier than what we did for some of the other problems. Okay, now you can't always do this. You have to kind of recognize the patterns, or you could try this. So our x-intercepts, we're looking for a degree is 3, we're looking for 3 zeros. So we've got negative 3, 0, positive 2, 0, and positive 2, 0. Y-intercept, plug in 0 for x, we're going to get 0, negative 12. Domain, negative infinity to positive infinity. Our end behavior, third degree positive lead coefficient, down and up, which means our range is also all real numbers. Third degree, maximum number of turning points is 2. Number of distinct roots, well, all 3 of these are different and distinct zeros, so there's going to be 3. So negative 3, 0, 2, 0, and negative 2, 0. None of these are bounces. None of these were double zeros. My y-intercept is negative 12. Let's draw this one. It's nice when we can actually draw this to scale. There's our 0, negative 12. Our end behavior is down. So after the most leftmost 0, we're going to go down. This one, let's see. We're going to go up on this side, down on this side. I know I'm going to go up here. I don't know how high. And then down here, I don't know where we hit. So you know what? I'm going to go ahead and graph that rather than guess. Okay, so let's look at this last one. So there's our max. Calculator went to sleep. Let's find that one. Menu 6, analyze graph. We're finding a max because it's a high point. And let's go to the left. There's the top point, so we have to go to the left, a lower bound, an x value that's below it, and an x value that's above it. And let's see, let's grab it, move it out of the way so we can see it a little better. Okay, 3 decimal places, my y value is 1.12. Ooh, for once I was close. Look at that. 1.12 and negative 2.5. So that's going to be about right here for that max. So negative 2.528, comma, 1.128. 128. Okay, now let's find this one down here. Let's change our window. Menu for my y min, I need to go lower. Let's go negative 25. Is that enough? Sure, that's enough. Okay, so we want to find that point. It looks like it happens after our y-intercept, so it's going to be somewhere over here. Okay, so menu 6, analyze graph. We're finding a minimum, a low point. So 2. We go to the left of that minimum, to the right. Sometimes the calculator plops stuff on top of each other, so I'm going to grab that and move it out of the way. Okay, so 0.52, and hit enter again to let go of it. So about 1/2 to the right and down 13. So about here. 0.528, comma, negative 13.129. And that's a low point. Don't forget your arrows. And looks great. All right. Thank you all for watching. You're going to do the next, I believe, 3 pages for homework. Try those out. I will post answers and see you all soon.